All right. So, listen. If I have a coefficient of 2 out in front of this whole formula here, how many silver ions do I have? 2. If I have a coefficient of 2 out in front, and the formula only shows 1 nitrate here, how many nitrates do I have? 2. Okay? Alright, so now we've done this. Okay?
Where did that 2 come, I mean, not 2, the plus in front of the 2 come from?
That's we've got 2 separate ions now.
Oh, you adding them.
Yep. Okay? Alright. Shh. Listen. Listen. Using this same thought process, can you write this one now in the ionic form? Please do that. Please write the ionic form for those. Okay? Yes, Bailey? What? Yeah, I guess so. I was going to have you do this one for us, but I guess I'll let you go to the bathroom. So while you're in the bathroom, I'll let Dick do the next one. Okay? No, there's 2 coefficient 2. The subscript 2 on the chlorine, when you make an ion, there are 2 chlorine ions, chloride ions. Cl is 1 negative. The 2 chlorines become 2 Cl negatives.
So just take the subscript and put that in.
Pretty much. You know, you don't do that. It's just like you don't have the subscripts travel unless they're part of a polyatomic ion. It's also true that you don't use the subscript unless it is part of a polyatomic ion in the complete ionic equation. Exactly. Exactly. The 2 doesn't travel because it's not part of a polyatomic ion. So when you're writing AgCl over here, this 2 didn't travel. It's also true that this 2 doesn't travel down here. It becomes a coefficient. Okay?
Hold on, don't do it yet.
Okay, I won't.
Mr. Dennis,
Yep.
when you're doing the charges, do you put the number in the plus sign?
If it's a 2 negative or 2 plus, yeah, you write it 2 plus, not plus 2. Okay?
Dang, girl.
You okay? Yes, ma'am. So far, except for this, the coefficient, the subscript 2 on the chlorine doesn't travel over here, and it doesn't travel down here either. If there are 2 chlorines bonded to this magnesium, then there are 2 chloride ions. Okay?
Okay.
All right.
Oh, this is my question that might get me when I'm doing something. How do you determine which charge to use for, like, if chlorine got a lot, but I chose -1, I mean 1 negative.
Okay. Magnesium, if you don't know which one to use, and you have to figure it out, if it's a 2-part compound like this, I'm going to look and see magnesium is 2 plus. Well, the thing's got to be 0 when I get done. I got to have a neutral compound when I'm done. So whatever charge is on the chlorine, it's got to be some kind of a negative charge.
Okay, I got you.
Because it's got to neutralize. You've got to be able to add everything together. Remember this formula or equation we're using? Got to be able to add everything together to get a 0 overall. And in MgCl2, I've got 1 Mg and 2 Cl, so what charge has to go there? -1 negative. Okay? So that chlorine's got to have a negative charge. Alright? Okay. Alright, Dick, break this up for me. Tell me what to write. I pretty much just told you that. Alright, look. Is this an ionic compound? How do you know? Alright, listen please. listen please. Everybody listen. I know this gets boring sometimes when I repeat things for the 50th time or something, okay? But you know it's an ionic compound from the formula if it's made of a metal, non-metal combination, or if it contains a polyatomic ion. Is this an ionic compound? Okay, because it's metal and non-metal. It breaks up, when you write ionic equations, it breaks up if and only if it's both ionic and aqueous, or if it's both acidic and aqueous. Has to be both, okay? So are we going to break this one up? Yes, we are. It's both ionic and aqueous, okay? You said it was ionic, didn't you? And you break it up if it's both ionic and aqueous, okay? Yes, yes. All right, so we're going to break it up. So we got magnesium and we got chloride. Okay, now we need to know what charges to put on there. Where do I find the charges to put on there? On that, yeah, you got it. That's the correct one. That's the periodic table of oxidation number. So let's find a charge to put on magnesium by using that. Okay, so we're going to make a 2 plus superscript here. What about for the chlorine? It's got to be 1 negative for this reason I explained down here. Okay, so we got the charges. How many chlorines or chlorides do I have? Okay, we have 2 chlorides. This 2 doesn't travel down here just like it didn't travel over here, James. Okay? This means there are 2 chlorides bonded to this magnesium, but we're breaking it all up. And if we're breaking it all up, that means I have 2 chlorides. Okay? All right. Colton, if it's aqueous here, what physical states do I assign to these? Aqueous. Now I've kind of bunched these up. It's going to be hard to see it all. That's the way it's supposed to come out. Okay? I could rewrite it, I guess, and make it a little bit neater for everybody. So we've got 2 silver ions that are aqueous. We've got plus 2 nitrate ions that are aqueous. Okay. We've got a magnesium with a 2 plus charge, aqueous. And we've got 2 chloride ions that are aqueous. Okay? So we've got everything on this side of the equation. We're ready to go to the other side of the equation. Okay? So based on what I've told you now, everybody, if you haven't already, figure out what to do with these and write them down in your complete ionic equation. Sure. What do I write for this? 2Ag, 2C, 2C. No. To break it up, it's got to be both ionic and aqueous. If it's not both, it does not break up. It stays exactly the same. Well, I'm sorry, there was some misunderstanding, but if it's not both, you don't mess with it, basically. It stays exactly the same. Okay? So we're just going to write that exactly the same way. We don't want to change anything. It has to be both. Either ionic or ionic and aqueous, or it can also be, well, I threw that example away, but it could be acidic and aqueous. Anything else doesn't break up.
That's what I thought, because
Okay. All right. All right. Yes, it does. Let me give somebody else a chance. Okay. All right. You've had lots of chances today. We'll call on some other people. I'm spreading the misery around. Let's let Marissa do one. Marissa, what do I do to this one? Yeah, really. Why not?
Would you combine the magnesium and the polyatomic?
Why would I do that? What are you thinking?
I guess just add the magnesium.
All right.
Aren't you like on the
Is it? Huh?
Aren't you on the bottom one?
I'm writing this out right here. This is the complete ionic equation I'm trying to write.
Yeah, and it's broken up.
All right. Is it what now? Okay, so you want me to put magnesium down here? Okay. And I'm going to write aqueous next to it? Oh, okay. I'm sorry. I misunderstood what you were asking me to do. All right. Is there something else I need to do here?
Yeah, put a 2.
Why would I put a 2 there?
Oh, wait, you don't have to carry that? The charge.
It's 2 plus.
Okay, Marissa, if I'm going to break this up, and in fact I should, it's ionic. I know it's ionic because there's a polyatomic ion in it. If it's ionic and aqueous, I'm going to break it up into separate parts. The magnesium breaks off from the nitrate, but the nitrate being a polyatomic ion tends to stay together. But I need to know what charges to put on them.
You put the 2 plus on the magnesium, and you put the 2. I think it's the 2 on the.
Okay, where did you get the 2 plus for the magnesium?
Just right before it, magnesium has the 2 plus.
Over here? That's a good place to look, but you can't always depend on that. But
And you know magnesium has the 2 plus.
okay, well if you just knew that, that'd be great. All right, so what about nitrate?
Is that 2? Is that the 2 plus? Oh, you have to put aqueous. You got it.
Okay, put aqueous on it. All right.
You put the 2 plus charge on the nitrate too.
Nitrate doesn't have a 2 plus charge. Where do you find the charge that goes on a nitrate? Get your test references out and find your common ions list. All right, hold it. I'm sorry. Guys, the only person I gave permission to talk, was Amber. Okay? Now, I've tried through this entire semester to let you whisper to each other.
Okay. Why did you put the 2 in front of the CL? Why you couldn't put it like you was before?
In front of this?
Yeah.
Because this is actually breaking up into separate things. Okay? This subscript is not part of a polyatomic ion. So it doesn't follow down here. It doesn't travel down here just like it didn't travel over here.
Okay.
Okay? If it doesn't travel down here, then what I'm showing is 2 separate chloride ions. Okay? All right, so what charge do we put on this, Marissa?
1 negative.
1 negative. All right. What about this 2 down here, up here? What do we do with that?
Yeah, you have to put the parentheses around the 3 and put 2 on the outside.
Okay, that in fact is not what we do, and here's why. It's the same thing as this 2 on this chloride. The nitrate,
Yeah, you don't send the.
that's right, it doesn't travel. If we break this apart, we're breaking off 2 nitrates from the magnesium.
Hey, would you put a 3 in front of it?
You put a 2 in front, yeah, right there. Okay? So now we've got a complete ionic equation. What do we do to find the net ionic equation?
I got to finish. You
Okay.
have to get rid of the ones that are the exact same thing.
So we're going to get rid of, what do we call those?
Coefficient.
No?
Yeah,
Spectator ions. Spectator ions. So,
and the nitrate.
Rob and everybody else, if you haven't written this complete ionic equation out, write it out. Put a single line, a single diagonal line through the spectator ions and write what's left. Spectator ions are any ions that are exactly the same on both sides. Exactly.
Spectator ions.
Okay? You're going to cancel out the spectator ions and write a net ionic equation. This is the complete ionic equation. Now we want to write a net ionic equation.